Hello friends, till now we have had a discussion on the system development life cycle, and we talked about the attributes of system analyst. Now let us take a look at the tools which are used by system analysts, right? So this is going to be the discussion today. Now I hope you remember that the system analysis is a very important aspect of the whole SDLC, and system analyst plays a very crucial role. What is the job of system analyst? He actually talks to the customer, finds out the requirements of the customers, and then translates these requirements into technical specifications so that the system designer can understand. The system designer does not interact with the customer. It is for the system analyst to interact with the customer. So he is basically a bridge between the customers, between the users and the system designer, and he has to have knowledge of both the words. He should know a little bit about system design aspects, also the technical requirements, and he should also be good at and we have seen this earlier also when we talked about the attributes of system analyst. He should be able to understand the requirements of the users also, and not only the stated requirements but the unstated ones as well. So this is a brief about the importance of system analyst and the role that he plays in the system development life cycle. Now let us talk about the tools that he is using and why are these tools being used. Through this, the system analyst is doing what? It is capturing the user requirement, understanding the systems which are in place at the user organization, and actually relates them to the designer. So the job of the analyst is to let the designer know what all systems are in place, what all are the practices, what all processes are there in the user organization. So that has to be communicated to the designer, for which he uses these tools. So the first one is called the data flow diagram. Let us understand what a data flow diagram is. Graphical representation of flow of data. How the data is flowing in the organization. It is represented in a graphical manner in the form of a picture, and all these things are shown in this kind of a diagram. Where is the source of data and where does the data go? So what is the source of the data? It could be some external entity, it could be some internal database, and where does the data go, right? And how is the data processed? Are there various steps involved in process? Maybe 1, 2 or 3 steps involved, or there is just one single step involved. So how is it going to be processed? Where is the data, the output is going to be stored? So the store of the output is known as the sink, and where the intermediate data storage is working, and how does it work? Now what is the difference between the data storage here and the intermediate data here? See, here the data storage is the processed data. So where do you keep the processed data, right? And here we are talking about the data which is not completely processed. It is in the middle of the processing operation, and it is actually being stored so that it could be again processed. It could be processed again. So that is why we are basically storing the data, and that is why we call it the intermediate data storage, right? So all these things are basically represented in this particular data. So where does the data go? Here. And where does the data come in from? It could be coming in from some internal database, it could be coming in from some external entity. So everything, and how is it going to be processed? What is the sequence of processing? Are there any intermediate data storage in between the processing stages? So all this is actually shown in this particular diagram. Now please understand, we are going to discuss only a very simple version of data flow diagrams. There are a number of variants of data flow diagram, but we are going to discuss only the very simple ones, right? Now this is how a data flow diagram looks like, and these are the various shapes which are used in a data flow diagram. You can understand the circle is showing the processes in their sequence. You see here, now If a circle is there, or let's say if an oval is there, it is basically denoting a process, and 1 denotes the first process, 2 would mean the second process. Now open box, it could be open on one side, at times it is open on both the sides, 2 sides. So that is basically the data storage. The data is stored here, and this is what is being denoted by this open box, right? We show the external entity by this closed box. Now this closed box, this is closed on all the 4 sides, and this is showing the external entities, and the movement of data and its direction is shown by the arrow, right? Is this understood? So this is how we have a data flow diagram. Now let's have a look at the actual data flow diagram, just to try and understand what is happening. But please understand, I hope you understand the notations here, and I hope you understand the symbols also. I hope you remember that this is a process, because this is a circle process. So this is a process. The first process is this one, 1.1, right? This one is the second. We had said that the processes as well as the sequence is also, both of them are shown in the data flow diagram. So 1.1, 1.2 and 1.3 refer to the sequence of operations, actually sequence of processing operations, right? Now I hope you understand that this is the external entity, box closed on all 4 sides, external entity. What about this? This is not the external entity. These are boxes, but they are open on 2 sides, closed on 2 sides. And what are these? I hope you remember that these are data stores. Do you remember this? We have seen it here. Have a look. These are basically data stores, or the files where you are storing the data within the system. This is the external entity, and this is the movement of the data. Now what happens here? Let's first of all find out, just to interpret this diagram for you. See, a student is there, external entity, which is not part of the system. A student is basically sending a test request, right? Once this test request is received, now what is happening? The first process that is taking place is checking. The request is being checked. Now please understand, in the meanwhile we are getting this student ID record from the internal file that we had, the student file, and we are getting this test ID record from the test file. So these 2 things are happening, and we are basically trying to check all the 3 pieces of information. One is the student request, then the student ID, then the test ID, right? If the request is valid, what we will do, the second process is the student would be registered, and the data would enter another file which would be known as test registrations. This file would probably maintain the data of all those students who have been registered, right? It could be that this is a late test request, right? Now this is another thing that can happen in that case, because now we have found out, we received the request by the student, we have received the information from these 2 files, student and test files, and we can understand that okay, the request is a late test request. In that case, the registration is confirmed, and this information is then conveyed to the student. And in case this request is found to be invalid, this particular information is again communicated to the student. So the student may get this communication that your request is invalid, or he may get this communication that his registration has been confirmed, or he may finally get himself registered. In that case, his name would be entered in the test registration file, right? So this is how the data flow works, and please understand, what is the system analyst doing? System analysis is basically understanding the operations of the organization, and then he's converting those operations into this kind of a technical language, this kind of a data flow diagram, and the designer will now have a look at it and will understand the flow of data, where it has to be stored, where the files need to be created, and then he can then design the whole system, right? Now let's talk about the decision table. What do the decision tables do? Okay, let us understand what they do. They assemble and present complex decision logic in comprehensible manner. So what do? They assemble, they collate and present complex decision logic. Decision logic is what decision you can take. For that you will have to follow certain steps. You have to take into account certain constraints. So all that is part of the decision logic in a comprehensible manner, in an easy manner, right? And then naturally Once this has been done by the analyst, now analyst will prepare this decision table depending on his interaction with the users, with the customers, and then he'll give it to the designer, and the designer and the developer will then finally write the software program according to what they have been told through this particular decision table, right? So the decision table is helping in coding of the decision logic into the program. So software programs will be prepared according to this decision table, and the decision table has been actually made by the system analyst after having interacted with the users, right? Now this I'll again interpret this particular decision table for you. Now here there is a certain situation wherein there is a particular chemical lab, or let's say a particular facility which provides chemicals to the other departments in the organization accordingly to the basically this is a chemical issuing department, you can say, and they are basically doing what? They are providing chemicals as per the requirements of the various other departments. But for that there is a particular process. The request should come, and if the request is coming, it should come from an authorized individual, right? Secondly, naturally the chemical should be available. If the chemical is not available, how can they actually issue that chemical? Thirdly, if the chemical is hazardous, they can only issue it to somebody who is trained on handling these kind of chemicals. So if the person who is requesting the chemical, if the entity who has come with the request for chemical issuance, that particular entity is not trained and the chemical that they are requesting for is hazardous, then they cannot issue. So these are the aspects that have to be kept in mind while issuing the chemical by this particular department. And for that now we have a decision table. Now please have a look. See, requester is authorized, chemical is available, chemical is hazardous, and requester is trained. Now the first thing that we'll do is to check whether the requester is authorized. False would mean no, and true or T is denoting that particular condition applies, right? Now please understand, there are cross signs which could be seen here, and these cross signs basically are depicting which particular action is warranted, right? So here, for example, this cross sign shows that in this particular case, this particular action is warranted. You have to accept the request, right? Now what are we going to do here? If the requester is authorized, this does not apply here, false. Naturally you cannot issue the chemical. Have a look here, don't issue. This cross sign is basically showing which particular action you can go for. So you don't have to issue, you have to reject the request. Now have a look at this particular case. Here the requester is authorized but the chemical is not available. Again you cannot issue, like here. Here the requester is authorized, T means the condition applies, the chemical is available, and chemical is not hazardous. F means chemical is hazardous, does not apply. So chemical is not hazardous. Now in this case you can issue, and you see this X here which shows that you can accept the request. Here the requester is authorized, chemical is available, chemical is hazardous, and the requester is not trained. Requester is trained does not apply means requester is not trained, so naturally you cannot issue, and that is why reject the request. And here the requester is authorized, chemical is available, chemical is hazardous, but the requester is trained as well, so you can issue, and this has been shown here. Now this is giving a brief idea to the reader as to what he can do and how he has to deal with the various requests for issuance of chemicals, right? So now let us move over to the decision trees. Now decision tree is a counterpart of decision table. Please understand that when there are a number of logics involved, you simply cannot use a decision table, because then it would become very complicated. It would not be easily comprehensible. So in that case you go for a decision tree. So decision tree also represents the program logic when there are too many decision alternatives. So when the decision alternatives are too many, then it is always advisable to go for a decision tree rather than going for a decision table, and have a look at the various alternatives which are there basically here. Now this is a case of a company which wants to increase its sales and it wants to increase its profit, and the various decision alternatives have been given here. They want to increase sales and profit. They can expand the advertising, they can expand the sales activities. When they expand the advertising, whether they are going to go for a new firm or they are going to continue with the current firm. When they are going for the new or the current firm, what if they increase the budget by 10%, and if they increase the budget by 5%, what happens? And these are the outcomes, what might happen. If they continue with the current advertising agency, these are the outcomes which might happen. If they instead go for sales activities and they work with agents rather than having their own sales force, and set up own dealers and continue with existing dealers, these are the two alternatives that they have. These are the outcomes that they will achieve. And if they use their own sales force, and within that again they've got two options: you can hire new staff, you can expand your sales force by hiring new staff, or you can motivate your sales force so that they can sell more. This is the other alternative. In that case also, these are the decision alternatives that you have. So in this particular decision tree, we have basically put onto paper all the possible decision alternatives and all the possible outcomes that can be there. Now once the decision tree has been made, it has been documented by the analyst. Now the designer and the developer can have a look at it, and they can accordingly design and develop the information systems. This is fine. So this could be a decision tree for an expert system. I hope you remember our discussion on expert system. Now this seems like a decision tree for an expert system. What will happen? The expert system will ask you questions, right? The expert system will ask you question: how much increase in sales do you want? Let's say you say, okay, I want to achieve an increase of 20% in sales. Now this is what you will respond to the queries posed by the expert system. I hope you remember that the expert systems pose queries, and then you have to respond, and depending on your response they will tell you what possible alternatives do you have. So you say, okay, fine, I want a 20% increase in sales. Then probably the expert system will tell you this. Then if you want your sales to be increased by 20%, if you want, then what are the possible alternatives? Another query might be posed by the expert system: do you want to go for advertising, or do you want to go for sales activities? And supposing your response is sales activities, then the expert system will tell you that go for sales activities, work with your own agents and set up your own dealers if you want to achieve this target of increase of 20% in sales. So this is how this decision tree is working. So this could be used to design and develop the expert systems, right? Now let us move over to the pseudocode. I hope you remember our discussion on what code is. I hope you remember that the software programmer is actually writing the codes. Basically, codes are instructions to the computer written in a technical language. It could be written in C or C++ or languages like this, right? However, pseudo means false. Pseudo means not real. So here we are going to talk about codes, but they would not be real. Let's have a look how. Let's have a look at how. We know that codes are instructions in the programming language, and the software programmer actually writes the codes. Now, here pseudocodes are not written in the programming languages. They are written in English actually. They are the programming logic, but they are written in English, and that is why we are using the word pseudo. So they are written in general English. They are not being written in C or C++. Why does this happen? Who is making use of these pseudocodes? It is the analyst who is actually writing these pseudocodes so that the designer can understand it. Analyst is basically interacting with the customer and the user to understand their requirement, and then he is writing the pseudocode depending on whatever he has found out from the user or the customer. And this pseudocode now will form the base for the designer and the developer, and they can write these software programs, technical programs, using the actual coding and the actual technical languages like C or C++, or there are so many other languages, and they can actually prepare the programs for the information system. So this is what the pseudocodes are going to be used for. Now see how pseudocodes are written. In pseudocodes, constructs like these are used. Now these are called the iteration constructs. Iteration constructs, basically they will direct you to do things again and again until something happens. So what are iteration constructs? Repeat until. So for example, if I want my computer, I'll just give you an example, to print numbers, digits from 1 to 5. So what will I do? I'll say print 1, add 1 to 1, and repeat step 2 until the result is 5. Right? So the computer will keep on repeating, keep on printing 1, 1, 1 until 1, 2, 3, right, up until the point it reaches 5. Right? So this is the iteration construct. Again, do while is another iteration construct. So we may instruct and basically we are not using it. See, again, don't get confused. These are not being used to actually instruct the computer. Based on this, the designer and the developer will write the program in technical language. So they will convert this kind of a pseudocode which is mentioned, which is written in English language, to the technical language which the computer can understand. Computer cannot understand this language. I'm just giving you an example to make you understand. So do while again is an iteration construct. If then else is a selection construct. For example, if student is equal to BBA 6 semester, then specify the date for Viva, dissertation project Viva. If the student is about 20 years of age, let him apply for the post. Else would mean otherwise. If the student is less than 20 years of age, mention you are ineligible. Now this could be a pseudocode for a system which is used to accept applications from various candidates who are above 20 years of age for a particular post. So the code that has been written is, if the student is less than 20, if the student is more than 20, let him allow for the exam, let him sit for the exam, allow him for the exam. Otherwise, else don't allow him. Otherwise, mention that he is ineligible. So this we can write using this selection construct. If age greater than equal to 20, issue admit card. Else, mention you are ineligible. So this is how we are going to actually write down the pseudocodes, and then based on whatever we have written as pseudocodes, the programs would be then written by the developers. Fine. And there's no use of programming language in pseudocode, and that is why the term pseudo has been used here. The objective is easy comprehension of the various sequences of operations. So what is the sequence of operation? What does the process actually entail? What all things are being done? Everything is specified using the pseudocodes, and this will enable the analyst to communicate to the designer as to how the process runs. What all steps does the process entail, right? And then based on that, as I said earlier also, the developers can write down the actual program. Fine. So I am repeating that pseudocodes are not meant for the computers. They would not be able to, the computers would not be able to understand this general English, plain English. They are meant for the designers and the developers who use it to write their own technical programs which can then be understood by the computers. Fine. So this is what the pseudocode does for you. With this, we have now wrapped up our discussion on the various system analysis tools which are used by the system analysts, and we have also wrapped up our discussion on Unit 4. As far as Unit 5 is concerned, I hope we've already had a number of classes wherein we have discussed the case of Uttarakhand State Road Transport Corporation, how they implemented a transaction processing system, and how they can in future make more extensive use of the data collected through that transaction processing system to improve their efficiency. We also had a look at the improvements brought about by various businesses, including the Walmart and including some local organized retail stores here in Pithoragarh also, by installing various MIS in their outlets. So in that sense we have completed unit 5 also, and now we have completed the syllabus in this particular subject. Please prepare well for the exams. Thank you very much.